Okay, let's dive into this explainer. Today, we're looking at a deceptively simple piece of engineering that solves a massive, incredibly expensive problem on a drilling rig. In the source material we're covering today, specifically episode 36 of their curriculum, we're talking about the Kelly Saver sub. At first glance, it just looks like a short, thick piece of pipe. But as we're about to see, this single component is an absolute masterclass in industrial problem solving. The $25,000 question. To really understand why this part exists, we first have to look at a huge financial and operational dilemma right at the heart of the rig. So on a drilling rig, the Kelly is this heavy, precisely machined steel bar that transmits torque to the entire drill string. It's a highly critical, really expensive piece of equipment. If you wear out the bottom threads on it, well, you're looking at replacing a part that costs upwards of $25,000. And that doesn't even factor in a potential 6-week lead time while a new one is machined and shipped out to you. When you've got a whole crew standing by, waiting is just not an option. On the flip side, you have a simple sub, a substitute connector that costs maybe $1,500 and is sitting right there on the rack, in stock and ready to go. Which one would you rather replace? And honestly, replacement isn't just a possibility here. It's a mathematical certainty. 500. That's the number of times the bottom thread of the Kelly is made up and broken apart during a typical well. Think about that. Every single time you add a new 30-foot joint of drill pipe, you have to unscrew the connection, add the pipe, and screw it back together under massive torque. 500 brutal grinding cycles. That bottom thread will absolutely die long before the rest of the tool does. Enter the hero of our story, the Kelly Saver sub. This is the incredibly clever solution to our $25,000 problem. Instead of letting the Kelly take all that abuse, engineers designed this short, cheap, sacrificial connector that screws directly onto the bottom. And this brilliantly illustrates the core concept. Think of it exactly like a screen protector on your smartphone. When you drop your phone or toss it in a bag with your keys, that cheap plastic protector gets scratched to pieces. You just peel it off in a minute, throw it away, and the $1,000 screen underneath is perfectly pristine. The Saver sub does the exact same thing for the Kelly. It takes all the damage, leaving the expensive machinery totally untouched. In practice, this means the actual, expensive thread on the Kelly gets cycled just once. You screw the Saver sub onto the Kelly at rig up, and you just leave it there. Every single one of those 500 connections to the drill string is now made on the sub's bottom thread instead. When that thread inevitably wears out, swapping the cheap sub takes a rig crew maybe 20 minutes. That's a huge difference from sending an entire Kelly away for weeks of rework, saving immense amounts of time and money. The hidden job, saving the casing. The Saver sub doesn't just protect threads. It actually has a secondary, highly critical function that is often completely forgotten. What's really fascinating is that this part provides a totally different type of protection. Most Saver subs feature a thick rubber protector ring fitted around the outside of the steel body. As the drill string rotates deep underground, this rubber ring rides directly against the inside of the well's steel casing. This physically prevents the massive, hard steel Kelly from rubbing and grinding against the casing wall as it spins. So why does this matter? Well, because casing wear is completely invisible. You literally can't see the inside of a pipe thousands of feet underground. If the steel Kelly rubs against the casing, it'll slowly grind the wall dangerously thin. You won't even know what's happening until the day a well control event occurs, the casing fails a pressure test, and you have a catastrophic blowout on your hands. That cheap rubber ring is holding the line against an absolute disaster. When protectors become destroyers, any safety device is only as good as the maintenance behind it. And when we ignore that maintenance, things go bad quickly. Here is the strict, absolutely crucial rule of the rig. The Saver sub must be treated as a consumable. It needs to be gauged on a strict, scheduled basis, just like anything else that wears out. You replace it when it hits its engineered wear limit, not just when it visibly fails or snaps in half. If you ignore that rule, you run into a brutal irony, as this quote perfectly summarizes. A neglected protective part becomes the cause of the damage it existed to prevent. This catches crews out all the time, and it's so frustrating because it is entirely preventable if you just respect the equipment's limits. Here is exactly how that failure plays out. If you run a Saver sub far past its wear limit, the threads degrade so badly that they gall. That means the metal actually smears and fuses together under extreme friction and pressure. The sub seizes permanently onto the Kelly. Now, the only way to get it off is to apply massive, destructive force, which destroys the exact $25,000 thread the sub was originally fitted to protect. The big picture, pattern recognition. Let's zoom out a bit and see how this builds into something much bigger. The Kelly Saver sub isn't just an isolated clever trick. It represents a fundamental rig design philosophy. If you look around a drilling rig with this new perspective, you really have to ask yourself, where else does this pattern repeat? Where else do engineers intentionally put a cheap part in the line of fire? Well, the answer is everywhere. In fact, the source material points out that if you've been following their broader curriculum, you've seen this exact pattern multiple times, like the bit sub protecting drill collars back in episode 13, wear bushings protecting wellhead seals in episode 21, and now here in episode 36. Brake blocks exist to be ground into dust so the metal brake flanges don't have to be. Bumper blocks up in the derrick are designed to be crushed to protect the highly tensioned drilling line. These are completely different systems, all sharing the exact same industry-wide design standard. So the crucial point is this concept, wear budgeting. In heavy industry, wear is not an accident. It's an absolute certainty. Wear budgeting is the practice of purposefully putting a cheap, easily replaceable component directly in the load path. You're intentionally dictating that all the inevitable connection cycles, friction, and damage land on the cheap part instead of the permanent machinery. Good design chooses what wears out. This brings us to a really beautiful, overarching truth to wrap up everything in this explainer. Good rig design, and really good engineering in general, isn't about magically preventing wear. That's defying physics. It's literally impossible. True engineering is about deciding in advance exactly what gets destroyed. You choose your failures, you schedule them, and you budget for them. You control the chaos by giving it a very specific place to happen. So, I'll leave you with this final, provocative thought. If wear budgeting dictates the survival of multi-million-dollar drilling rigs, what other hidden screen protectors are saving the massive systems and industries all around you every single day? Once you start looking for these sacrificial heroes, you'll see them absolutely everywhere. Thanks for joining me on this explainer, and keep your eyes open for those hidden patterns.